Hi there, this is Penelope, FS3128, topic 7, class 5, still in the first section of trigonometry where we're looking at right angle triangles. Here's a problem where we could read the answers off the graph. Now, that's fine. If you've drawn the graph, you could find it, but we need to be able to move on from finding this. What we would usefully find is, say, sine inverse of 0.9063 equals x. So what we're trying to find are the values of x that make this sine. So what value of x has a sine 0.9063? And we can use then the identity from the previous class to give us that x is equal to 65, or 180 minus 65, which would be 115. So what you're doing is you're using sine 180 minus theta is equal to sine theta. So use your calculator. Look up sine inverse of 0.9063. Now, that's only going to give you one answer. It's only going to give you this answer, 65. But use this identity to find the second one, as well as really thinking that in the first quadrant, quadrant 1, we've got theta, and in quadrant 2, sine theta is equal to, it's still the same. So that sine of 65 is the same as the sine is of 115 degrees. That's a pictorial question, but you also need to be able to do actual algebraic trigonometrical solutions. Let's have a look at the first one. Now I will do the second one and the third one in class, but look at the first one. Now if it's an ordinary equation, we need to get rid of that 3. So 10x equals 4 over 3. So then we can say that x equals 10 inverse of 4 over 3. Now we're in degrees, so that'll give us the answer of 53.1. But it's not enough. We know that tan is positive in which quadrants? Let me think. Tan is positive in quadrants 1 and 3. So we have to find the other angle that's the same. So all science teachers, it'll be in this quadrant, it'll be that one. Now to find the proper name of 53.1, so that little angle in there is 53.1, but we need to find its name, and its name will be 180 plus 53. So x will equal 180 plus 53.1, which is 233.1 degrees. So we need to remember so many things here: the identities, the quadrants, etc., etc. Solve 5 sine theta plus 3 is equal to 0. Okay, let's deal with each of these bits in turn. Let's move the 3 to the left-hand side. So then we've got 5 sine theta equals negative 3. Still not close enough. We need to get rid of the 5 just by dividing both sides by 5. Now, this allows us to use inverse sine. Theta equals sine inverse of negative, change it to a decimal point, 6. which is, if we look that up on our calculator, negative 36.87 degrees, which technically is correct. It just represents this angle in there. Now, where is sine negative? Sine is negative in here and in 3. So what we want are the proper names of those angles there. So theta is going to be 180 plus 36.87, which will be 216, or 360 minus 36.87, which is equal to then 323. So just be on the lookout. There's more than one answer. There is two answers. There are two answers in this particular question. Again, this is one that we could solve using a graph. We could draw the picture of cos 2x and we could see that what we're looking for there's about 0.5, so it's about here, 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 and here. Now, look at that. We've got 4 answers. So we need to make sure that when we've done our problem that we've got 4 answers. And in this kind of question, where you've got something like that, it's better to change, to make a substitution. So let's, because then we can write cos z equals 0.4384. Now here we've got, I'll write it down here, 0 is less than or equal to x, which is less than or equal to 360, but we want to be able to say something about z. So it's still going to be 0 is less than, or 0 is less than or equal to z, but now z is 2x, so it would be 720. So we're going to solve this. Z equals cos inverse of 0.4384. Now look that up on your calculator, and in degrees you get 64 degrees, and cos is positive in quadrant 1 and 4. So z is equal to 64 or 296, so that's 360 minus 64, or 64 plus 360, which is 424. That's 360 plus 64, or put it down in brackets first, 296 plus 360, which is 656. Now that's for z. It's for z, not, let's just underline it in red, that's for z, not x. Now we have to remember, but z equals 2x, so then we can find that x equals z over 2, and that'll give us the values for x. So we have to divide all of those by 2, so we've got 32, 148, 212, 328. And if we check, just write in there, check, all of those will be true. They will all give us the cos of 2 times each of those will give us 0.43884. This one we will do in class, but the first one we can do here. The first one says solve x minus pi by 2 equals negative 0.9, etc, etc, etc. Now we're here, we're in radians, so we just need to be a little bit more careful. Same thing, let's call z x minus pi by 2. So, we've got 0 is less than or equal to x, which is less than or equal to 2 pi. Now we're going to do the same thing for z. 0 minus 2 pi would be pi over 2, be negative pi by 2, and z would be less than or equal to 2 pi minus pi over 2. Okay, z equals sine inverse of negative 0.9453, and using the calculator that's negative 1.2385. Oops, 2385. So what we need to do, well, sine is negative in the 4th quadrant and the 3rd quadrant, so this angle here has to be 1.2385 for z. The same in here, it's got to be for z. So z equals pi, because this is pi, plus 1.2385, which is, use the calculator, 4.3, or z equals 2 pi minus 1.2385, which is 5. Now, that's out of range. If we do the numbers on here, that's out of range, so we need to subtract 2 pi, and that'll give us negative 1.2385. Okay, so x is equal to, well, to do that we need to go back up to here. So z equals x minus pi by 2, so x equals z plus pi by 2. Okay, so what we have to do is we have to add pi by 2 to each of those previous answers. So x equals 4.3801 plus pi by 2, or negative 1.2385 plus pi by 2. And we can work them out as numbers. The first one would be 5.9509, which just squeaks in under 2 pi, or using the calculator to find this one, 0.3323. Again, it squeaks in, it's above 0.